Okay. All right. Good afternoon, good morning, good evening, from anywhere you might be joining us from. My name is Oladapo Babalola, co-founder at daas.ng, DevOps as a Service Nigeria. So on behalf of my co-founders, Oluwaseun and Nodin Kamilu, I welcome everybody, our esteemed mentees to today's class. Right. So today we're going to be talking about CI/CD. And it's going to be a very simple and straightforward class. And we won't take too much of our time today because, of course, we're still going to continue again from next week. So whatever it is that we're going to do today is more like a foundation, more like the basics of anything that we're going to find in CI/CD today. Okay, all right. So before we go in, right, let's just have a quick sort of history of where we are coming from. So before CI/CD itself, how were we building products, right? Before the advent of what you have today as continuous integration, continuous deployment or delivery, how do we build our products, right? Now, if you can see my screen, right, the flow is usually that when there's a new bug or when there's a new product or when customers have actually complained about a new functionality that should be added to the existing application, for an organization, for a business, for a bank, what have you. They communicate that to the customer service, like the customer service of the organization. Then the customer service of the organization now forwards it to the product managers. Now, the product managers are more like the guys that actually, handle the project, on a business level. So these guys within the different organizations, they understand how the project works, like from the beginning to the end. Those are like the project managers. Those are the units that handles the project. For example, you can have a project manager that is in charge of, let's say, the internet banking app of a bank. Now, those guys are responsible for knowing the full functionality of how that app works, like from the login, to all of the links, all of the modules, everything that makes that app, to function fully as an internet banking application. Now, those are the project managers or the product managers. Now, customers have complained that they find it very hard to log in, or maybe they take like maybe 2 to 3 minutes to be able to log on to their app, which of course is like a bug. And I'm sure that the majority of you actually are aware that, there was a bank, earlier last month, that released a new version of their mobile app. And for 2 or 3 weeks, customers were complaining, that they're trying to sign up, they're not getting sign up mail, just different issues here and there. And I'm sure that bank actually, trend, like the bank for some time was actually trending on Twitter for 2 weeks straight. Now, what that means is that customers are actually complaining. In fact, even without reaching directly to the product, to the product managers, right? Of course, the product team or the product team lead, of course, would have seen the responses on Twitter. And what they have to do is to raise the bug. Now, raising a bug means that you are actually reporting all of those user experience issues. You are reporting all of those issues. You are reporting it directly to the developer. Do you understand? Now, that is what works today. That is what works, of course, today. And, from where we started, that was what was working. So the product manager reports the bug to this guy on the left-hand side, more like the developer himself. So this guy on the left-hand side over here is a developer. So the product manager reports the issue to this guy here. And by the time this guy works on the issue. You can see he's actually working on the bug, just trying to fix why the internet banking app is not working well. After it's done, he packages the entire application into what we call an artifact. It packages everything into an artifact. So you cannot see an artifact like a zip folder of everything he has actually worked on. For example, let's say to his own knowledge, he has fixed the bug. So he packages that artifact and then he sends it to this team here. These guys are the testers. Some organizations, they will call them as the QA. QA means quality assurance. But of course, you can still call them testers. This team would test the entire application again, just to ensure that the bugs that have been reported by customers have been fixed. So by the time these software guys, by the time they are done with testing, they forward it to the security guys or the security team. And this team, of course, they will run different penetration tests, different software to be able to scan the artifact that's been put together by the developer, to scan it just to ensure that there are no vulnerabilities, right? By the time this is done and that's been confirmed, okay, the final leg now goes to the server guy. It goes to, the cloud guy, or we are going to call the server team. Some organizations call them app admin. Some organizations call them sysadmin. Whatever it is, the team that is actually responsible for deploying the artifact to the target environment, right, is this guy here. You can see he's in the server room, trying to deploy the artifact. Now, traditionally, this is what works today. Now, what happens if it gets to the penetration testing team? They now discover that, there's an issue. Now, guess what will happen? The artifact would never get to this guy. It will never get to the server team. But instead, there's a feedback that will go back to the developer to say that this is the scanned report of the application, of the internet banking application that we have scanned. We noticed that based on the bug you fixed, this and this and this must have to be put in place. Now this guy works on it again. Maybe he has added some functionalities. He now sends it to the QA team over here. He sends it to the QA team. The QA team does their quality assurance tests. They do their functional tests, unit tests and all that. They now find out that, something is broken. We need to send it back to the developer. You will notice that since all this while, the end product has not gotten to this guy here to deploy, right? And that is the concept of what we call a lead time. Now, what is the lead time? A lead time refers to the time it takes for a code change or a feature request to move from the initial idea. Remember where we are coming from. This is the initial idea, right? So this is not the initial idea. The initial idea, comes from the customer. To move from the initial idea or request stage to being fully deployed and operational in a production environment. So you need to mark all of these terms because these are part of the questions they might ask you when you go for interview. Very common question. You are a DevOps practitioner. What is a lead time? You won't just say that a lead time is the time it takes for this, from this to this. You have to mention all of this. Now, remember, the definition is saying that from the initial idea, this is from the Twitter complaints, that is the initial idea. From the initial idea or request stage to being fully deployed and operational. So peradventure, it has gone to the QA environment, right? From QA environment, it has gone to the test environment. From test environment, it has gone to the staging environment, and the app is just sitting there. That is not lead time. Lead time is saying that it has been fully deployed and operational. Mark this keyword, and operational in a production environment. Operational means that whatever bug that has been worked on has been deployed to the production environment and the customers are no longer complaining. That entire cycle is what we call the lead time. Very important. Then, of course, it encompasses the entire software delivery pipeline from the moment a developer starts working. You can see that the developer is actually working here, right? Start working on a feature. That feature is whatever it is that the product team has communicated to him, to work upon. That is what we call a feature. Or a bug fix. A bug fix could be, something that takes time for a particular application to load. Maybe if it takes like 5 minutes for an application to load, then that means that there is a bug somewhere, right? So on a feature or a bug fix to the point where it is available and functioning in a production environment. Am I making sense? Am I making
Very well,
sense,
sir.
guys?
Yes,
Yeah,
you are.
good.
Yes, a lot.
Good. So you need to ensure that you understand what a lead time is. In fact, if you go for any interview, you will never miss this. And it's very simple. Just remember this diagram when you go for your interview. The developer, it goes to the software testing, it goes to the penetration testing. It can still go to some other departments, just for them to just ensure that the bug is no longer there before it gets to production environment. And it's what? Functioning, operational, available. You can see the choice of what I use there. It must be operational, it must be functioning, it must be available on the production environment. Now, what is now continuous? What is now CI/CD? What is a CI/CD? CI/CD is just continuous integration, right? And that is just the full meaning of the CI. Why the CD is what? The CD there can be used in two ways. The CD is continuous deployment and continuous delivery. Those two terms are not the same thing. Delivery is different from deployment, right? So, but today's class, we'll talk about only continuous integration. So by next week, we'll talk about the CD part. But just have it at the back of your mind that there's a difference between continuous delivery and continuous deployment, which is very, very important. So that at least once you go out and, they're talking about CI/CD, some people will say that you can use continuous delivery interchangeably with continuous deployment. It is wrong. There's a difference between continuous delivery and continuous deployment. That is the CD. But today, we're going to be talking about what? Continuous integration. Now, what is CI? What is continuous integration? Continuous integration, when we talk about the CI and the CI pipeline, right? We are referring to the steps, or we are referring to the series of steps that the code goes through in order to get from what? From your development machine through testing and staging, and then finally out of the door into your user's hands. So that in itself, so what I just defined is the CI/CD, right? It's just like the series of steps that the code goes through in order to get from the deployment machine. So this is the deployment machine here, the development machine through testing and staging, and then finally to the user's hands. That is just a simple definition of the CI/CD pipeline. Now, the CI is now talking about it is a practice. It's a practice that starts with committing changes first and foremost to a source or a version control system regularly, so that everyone is building on the same foundation. It now goes ahead to talk about that each commit triggers a build and a series of automated tests to verify the behavior and ensure that the change has not broken anything. Good. So this is more like the paper definition of continuous integration. Now, what does this mean? Continuous integration deals with when this developer, let me clean this board a bit. Okay, so continuous integration deals with when this developer, right, he commits his code to a VCS. So this is the VCS here. A VCS means a version control system. So committing his code is just saving his code base and all of the changes to a remote folder somewhere. That is just what a commit is. So as he's making changes, right, he's saving, and as he's saving, is saving not just to his local system alone, but is saving to a remote folder called a version control system. And the reason why it's called a version control system is because if it needs to roll back to an initial work that it did maybe like yesterday, it can easily roll back. That is just why it needs to always commit to a version control system. So the CI is a practice where this guy here, he commits his code, he saves his code to a version control system. After saving to the version control system, right, the code is now built. So whatever it is that is working on, by the time it hits the VCS, it is built. So you can see the building. You can see the building as compilation of the entire code base to become an artifact. That is just what a building is, which I'm still going to explain, right? So that is converted to an artifact, right? After conversion to an artifact, right, then that phase is called the CI, continuous integration. So the keyword there is continuous. So it means that this developer is continuously making changes. And as he's making the changes, right, those changes are committed to the VCS. Remember, this VCS is just like a folder somewhere sitting on the cloud. Now, by the time is committing and saving his code to the VCS, there is another tool somewhere called the build server that now picks up the changes and then builds it to an end product called the artifact. That is just a simple definition of the CI. Now, another important thing that you need to know within the CI is that whatever it is that you are doing within your CI pipeline and your CD pipeline must be automated. There's nothing manual in what you are doing. Everything must be automated. Now, what that means is that this developer here, in fact, let me just bring up my terminal and just act like a developer. So just imagine that I'm the developer. This guy here is trying to write his code. Like, I've written a sample code, and this code, is what we've been using from our Docker class, right? So you can still go to the repository to go and actually pull this code, and you'll still be able to pull it. Now, I am the developer. I'm trying to fix the bugs that have been reported, right? So let's say they reported that I should change the color of the app from green to blue. So let's say I change this to, let's say, blue, right? I'll finish working on the code. I am saving it this way. After saving it, right, I need to commit this code to a VCS. An example of a VCS root is GitHub and Bitbucket. I'm sure that you guys are actually aware of that, right? So what do I need to do? I've made changes. It is only residing on my local repository here because, of course, I made some changes here. I saved it. It has not gone to the VCS. It has not gone to the VCS yet. What I just need to do is just to, of course, we have done the class, it's just to add everything. right? It's just to add everything. And then, of course, I don't have to go through this again and check the status of what I just added, right? Okay, I've actually done something, but I've not actually, committed before now. So it just added everything that I actually need to commit over here. Do you understand? So what I just need to do is to do my git commit, the message of the commit. Maybe I fixed the bugs reported by the product team. Right? So after committing this, I just need to now after committing this, I need to now send it to my VCS, which we all know. Git push. Then I can set my upstream. Origin to my develop branch. So what I'm doing right here is that I've committed, you can see the command, I've committed and I've pushed. Now, immediately after pushing this, right, something is going to now build this particular application, because right now, this is just the code base. This is just the code base. I can't do anything with this. This is just like the code base. The customer cannot use this. Nobody can use it, but I need to convert it to an artifact. That is what a building does. But instead of doing this manually, I have committed this to my VCS, right? Then at the end of that tunnel, there is a build server waiting to first, before building, right? We need to do what we call automated tests. Now, what that means is that automated tests or unit tests, from the word unit, it means that whatever the developer has done here, even before it gets built, you need to have like an automated test to test all of the functions. So if you're a developer, of course, you are going to know what a function is. But of course, because you are a DevOps practitioner, you are not expected to be writing unit tests. You're not expected to be, understand all of the code functions. But it is a must for you to inform your developer that, look, before I complete my CI pipeline, let me have your unit tests. Now, what that means is that you are testing each block automatically to ensure that whatever variable or whatever function or whatever constant or whatever anything that's been written by the developer, it is tested automatically. Each unit is tested automatically to ensure that, for example, now, this function here is just saying that by the time we deploy this particular application, right? If the default color, right? If the default color is not specified, then just make the default color to be blue. So the unit testing is just checking to ensure that that function that picks the default color is functional. Now, for example, let's say the developer made a mistake here and let's say he just made a mistake and he just wrote rubbish here, right? If he pushes this to the VCS without automated testing, guess what will happen? It's going to build. This is going to build successfully, right? It might even get to the to the team responsible for running security vulnerabilities. It might pass. It will get to the QA, right? The QA might not even check this functionality. It will pass. It might actually pass. Now, when you now get to the production environment, the server guy is not testing anything. His own is, they've given me the artifact. Let me just go and deploy. By the time it deploys this, right, the customer is going to, of course, notice an issue. And guess what will happen? The cycle starts again. So Unit testing is there to be able to catch all of the code issues early enough before it even leaves the CI pipeline, before it even leaves the CI stage. So let's say I've made an error here and I've saved this, right? I've written a test script here. So in Go, you can actually write, you can actually write your tests, your unit testing to be able to test all of this automatically before even leaving the CI. Now, this is an example of a unit test that I've written. You don't need to know whatever it is here, but this is more like a policeman checking to ensure that whatever it is that has been written by a developer has been confirmed okay. But meanwhile, I've made a mistake here, right? If I should run the unit tests by just typing go test rather, here, can you see what is happening? It is telling me that something web form syntax error, unexpected expecting expression. This will not even build at all because of these unit tests that are involved here. This will not even build. So the feedback is quick and it's getting back to the developer to inform the developer that whatever it is that you are writing here, there's a mistake here. You can see that now you are now reducing the lead time that we talked about here. You are now reducing the lead time. Your lead time here should not be a large time. It shouldn't be a very long time. Your lead time should be at most maybe 5 minutes. Your lead time could be maybe like 2 minutes. But without the introduction of your unit test, your lead time can be as long as maybe like 2 days or 3 days. Everybody just trying to figure out where the issue is because you didn't have unit tests within the CI, right? So the feedback has gotten back to the developer. The developer have actually seen when the issue is coming from. And then by the time he corrects his code and save, and then do a go test here, you can see that it passed because everything is okay. So here you are running your unit test, which is very, very important within the CI. Very, very important within the CI. So now let's now go back to our board here. Now, what is now the full flow of a continuous integration? The full flow is, of course, remember, develop, the plan, the code. The plan is what? From the product team. They are planning how the app should function. They are planning how the app should be able to flow. If there will be a login, how the login should be. By the time a customer logs in, what is the customer expected to know and to see? What is the customer expected to see? Maybe when they click on a particular link and all of those things are actually the planning phase. And then the code is handled by a developer. So this is the first stage here. That is the develop stage here. The second one is what? The source control, which I just demonstrated, the commit changes. While the last one is what? Build and test. In fact, this is wrong. It should be test and build. It should be the other way around. It should be test and build. Now, what is it testing? It is performing what we call what? Unit test. So guys, please don't forget this part because this is very critical. Even we're not just teaching just for interview sake alone, right? But we are also teaching you the best practice. So if you have a pipeline, your CI pipeline, first and foremost, break it. Understand what your CI pipeline is first before even going to the CD. That's what most people just rush to just build a pipeline. Jenkins, they just launch Jenkins, they just check one video on YouTube and just follow it. You don't even understand what is going on there. You need to understand and ask yourself, is there a unit testing stage in whatever it is I'm doing? If there's no unit testing stage, return it to the developer. I'm not going to build this without you including your unit test. Very important. And of course, what? Unit testing and then build. So this is just the simple illustration of what a CI is, continuous integration. Any question?
Yes, I have a question, sir.
Please go ahead.
So I do. I have to tell the developer to include the unit and testing. I thought that it's their duty for them to do that before pushing the code to GitHub.
It's their duty to do what? Of course, now, it's their duty to include their unit testing. It's their duty to include their unit tests in whatever it is they are doing.
So
Do you understand?
how can I know if they didn't include the unit testing?
How can you what? You ask them now. You have to ask them if a unit testing or a unit testing script has been included, you know, in their code base. For example, now let me just show you something here. For example, let's say you want to build this into a Docker file, right? Sorry, you want to build this into a Docker image. Of course, we have done the Docker class. The first thing that you need to do is what? Have your Docker file, right? And within your Docker file, you as a DevOps practitioner, you are just including Go tests. Remember that what I was running here manually is Go tests. You're just including it here. And then you are passing the -v automatically, because this is Golang. Go is going to browse your present working directory to see if there is a test script. And it must always be the name of the application _test.go. So once you include this automatically, it's going to check this present working directory for the test units, for the test scripts, right, to run against. But if this guy is not there, then this Docker build that I'm actually doing, that I'm trying to run here, will fail. For example, let me just do something. Let me remove this. Let me place it here for now and run my Go tests again. Can you see? No test files, because it cannot find the unit testing scripts. And of course, if I should run my Docker build here, it's going to fail. And by the time it fails, you are checking the error, and then you are seeing that your developer has not included the unit test script here. So that is a basic way to be able to know that your developer has not included his or her own unit testing scripts. Secondly, you can also check the developer's repository. For example, now this is daas repository. Let's say this is the developer's repository over here, right? You are checking the different branches. Because we're actually working on a develop branch here, you would see the test scripts automatically over here testing, because I actually work with Go. I know that this is a unit testing script. So these are just the two ways that you can take to ensure that the unit testing has been included. So what you are doing is that you are following the best practice to include unit testing in whatever it is you are doing in your pipeline. And it is expected that the developer includes the unit testing scripts within it. Do you understand? So let me take this thing back.
Yes, sir. Yes, sir.
Okay. Any other question? Any other question before we move on? I just wanted to take this time to explain this part to you, because once you meet this part, right, you miss everything. So really, it's not all about the tools alone, but you need to understand the concepts. Unit testing is very, very important. Okay, let's go on. Now, what are the benefits of CI? Of course, it has low risk deployment, higher quality, reduced cost. What does low risk deployment mean? It means that by merging the code continuously as it's being written, you can address any errors that arise early on. Have you demonstrated this or not? The benefits. Have you demonstrated this or not? Please, I need responses.
Yeah.
Yes, yes.
Good. Now, higher quality. Automating a large portion of the manual tasks frees developers up to focus on higher testing, on higher level testing activities. Have we also automated the unit testing here? Yes or no? Although we've not run it, but at least we've discussed about it, which of course we'll run it now and then would check and see how this is actually done automatically. So of course it will achieve higher quality. Reduce costs. By implementing continuous integration, shipping in smaller batches and automating much of their work, companies can significantly reduce the cost involved in software delivery. So these are just the basic benefit. Of course, there are more benefits of having a CI within your pipeline. Now, suffice to say this, that there are some organizations that have only CD. I don't blame them. They have only continuous delivery, continuous deployment. There are some organizations that have only CI. I don't blame them as well. Do you understand? But the most important thing is that whatever it is that you have, be it CI or CD, you need to be able to reduce the costs involved in software delivery, right? Now, let us now move on to another very important part, the 9 steps of continuous integration. In some places, it could be 12, it could be 10, it could be 8, it could be 5. But this is what I've been able to put together, at least from my experience. Now, what are the steps, right? Number 1 here is that the developers check their code into the VCS. And VCS is what? The version control system. You can see they are writing their code. They check it into what? The VCS, which you can see here, right? So that is the number 1 flow. Number 2 flow, again, please take note of all of these flows because this is what they will ask you as well in your interviews. Explain a typical continuous integration, continuous deployment. Although we've not actually got into the continuous deployment part, but of course, if you're able to gain this knowledge, you'll be able to, combine it with the continuous deployment bits. So, step 1, what? The developers check their code into a version control system. What is a version control system? A version control system is what? Could be what? GitHub. It could be Bitbucket. This is just a version control system. You can see that it's just a folder that enables you to be able to, track all of your changes, things around pull requests. We have talked about version control system. We will not go into that. So let's continue with the flow. So number 2, the version control system here, right, notifies what we call the continuous integration server that a commit has what? Occurred. So the developer commits, right? Then the VCS informs the CI that the CI server, that Mr. CI server, something has happened. The developer has actually committed his code. It's just notifying the CI server. Now, what happens? So this is 1. We've talked about this. 2. Now, 3. What happens here between the CI server and the build server? Now, remember, the CI server, right, is like the manager of a restaurant that is in charge of, the restaurant activities, the admin things that actually happen in the restaurant. That is just the function of what? The CI server. Do you understand? Now, because changes have actually occurred here,
Can you sorry to cut you. Sorry to cut you. Can you take the
so the CI server, continuous integration server, is like the manager of the restaurant. Is the one in charge of all of the activities, is in charge of all of the cooks, is in charge of everything administration of a particular restaurant. That is just his own function, right? Now, by the time, so you can see this VCS as a customer walking into, to order his food, right? Information gets to the restaurant manager. The manager now informs the cook or the cooks to, prepare whatever it is that this customer has actually ordered. So that is just the function of the build server. So the information gets to the CI server, who is like the manager. The manager now informs the backend guy or the cooks to prepare the food. That is why you can see this arrow going up, to prepare the food. So these guys are the ones that do the heavy lifting. So they prepare the food, they ensure that everything is intact, the right ingredients and all. So the build server is now responsible for building the code. That is the code that you are seeing here. The webform.go here, it needs to be built, and this build server is responsible for that. Not the this build server. Yeah, so this build server can also be called build agents. Let me just correct this so that it doesn't confuse you guys. Let me just change it to build agents so that it doesn't confuse you guys. Yeah, build agents. So the build agents, right, is responsible for building the entire code base. So that is what number 3 does. So the CI server, who is the manager, informs the backend guys to build the solution. So this is what number 3, right? Let us go to number 4. What does number 4 do? Now, after this is very important. This is like a very important part. After the CI server has informed the build agent to build the code, something happens. And that thing that happens is that the build server, right, now checks out the code. Checking out the code means that it has a copy of this part of the entire code, base that is here. If you know, this is my code base, which is still the same thing as what I have here. So the build server copies all of this. It copies all of this code base, everything here. It copies it to a temporary folder on his server. So the build agent has his own server. The CI server, the CI server here has his own server. That is, the manager here has his own server. The build agent has his own server. By the time it informs the build agent that it should build the code, it checks it out. It checks the code out, meaning it copies the code temporarily. It doesn't cut it. It doesn't modify the source here. It just checks it out. It copies it to itself. And then number 5, what now happens? That code that has now been checked out is now built, analyzed, and what? Tested. So that tests, that testing that is happening is what we call the unit test. So that is what this build agent is doing. So instead of coming here to manually run, go test, go build, and what have you. Let me not show you what I'm trying to say here. So let me delete this. Remember where we're coming from in our last class. For every project or for every code base, they have their set of instructions for building the application. Golang has its own set of instructions for building. .NET has its own set of instructions for building. Node.js has its own instructions for building. Java has its own set of instructions for building. All of those building instructions, they differ. Very important. So how do we build the Golang? Remember where we're coming from. First, you have to what? Initialize the entire project. Go mode init. Let me call it daas class. Right? Okay, it's want me to tidy first. So sometimes you can see where I will go mode tidy. Right? Then you can run the go mode init again. Okay, so by the time you run this, it downloads what we call a dependency. I don't want to go back into this. So after doing this, what is the next thing? Go test, right? It passed, meaning I have run my my unit testing here and it passed. What is the next thing? Go build. Go build. What am I building? I am building my web form here. So you can see it has built it. So all of these manual things that is happening here will not be done by you. It will be done by this guy. It will be done by this build agent. It's as simple as that. So that is number 5. So number 5, what? It checks out the code and it builds it. Now, what is number 6? Number 6 is telling us that important results, that is after building this. Remember, once you build this, you have a web form.exe. Now, this exe is called the artifact because this is what is going to be deployed on the target environment. So the build agent, after building, it reports important results, such as what? The test result, just to ensure that the unit test that I ran was successful, right? Along with other important details and files. It sends it back to the CI server. So after the cook and the kitchen people, by the time they are done, they report to the CI server, or they report to the manager to say that, Mr. Manager, the food that you asked us to prepare, right, has been concluded. We are finished preparing the food. So the CI server receives it, right, and it sends it for deployment. Do you understand? That is number 7. So this 7th here, right, they are saying is just, if it failed, you will see that it failed. You see it as red. If it passed, you see it as green and whatever. So this is more just like a notification, so to say, which I'm still going to see once we start, doing it real time here. Now, that is number 7. Now, what is number 8? Number 8 is saying that if the build has completed, if the build has been successful, right, then the developer can now, take it from what the develop branch, maybe like to the master branch, so to say. You can take it to the master branch, but this is not usually compulsory at all times. That is why you can see these dotted lines, because of course, by the time this has been successful, the next thing is to go and deploy it and even see if it is running as expected. But I don't have to put this dotted line here just to tell you that this is not always, compulsory, because the only time that this needs to be made to the master branch, because if you should go back to my VCS here, if you go back to my VCS route, I have 2 branches. I have the master branch. You can see that here in the master branch, there is nothing here, because the master branch is usually the present representation of what is on production. But right now, I have not gone to production. That is why you can see that this branch here is empty. And that is what this step is saying, right? So if this is successful, there are some organizations that they will tell you that, okay, if your CI is successful, then the developer can raise what we call a PR, which you can see here, a pull request, to now merge to master, so that once it's on master now, it can now go to production. But it's not always compulsory for you. Again, this is very, very important. This is not always compulsory that because your CI is successful, then it should just go to master straight. No. That's why I say some organizations, they have only CI pipelines. They are okay with this. That so far it has passed, the unit tests have passed, security has passed, everything is okay. It can be merged. That is what this number 8 is doing. And then number 9 is that by the time this is successful, the leaders, that's the team lead and the testers and what have you, will get a notification that, the artifact is ready and what have you. So this part here, So this part here are just more around notification, And this part here, remember, this is not usually compulsory in all cases. But these other steps from step 1 to 6 is something that you must do. All right. Do you guys understand? I've just tried as much as possible to be able to simplify the entire process.
Yes, we do.
Any question before we move on to TeamCity?
Yeah, I have a question, sir.
Please go ahead.
Yeah, based on the CI, I'm a little bit confused on this. I know you talk about the build agent. The build agent, I believe it might be Gradu or Marvin that will do the build job. Then for the CI, is it either Jenkins or TeamCity?
No. These two here. Remember, I have not mentioned any tool. I've not mentioned Jenkins. I've not mentioned TeamCity. I've not mentioned CircleCI. I've not mentioned anything. Whatever tool that you're making use of, they must follow all of this concept that is here.
Okay.
Do you understand? They must follow all of this. Do you understand?
Yes.
So where your CI now comes into play, your CI, in fact, incorporates all of this, but the major component of the CI are just these two here: the agents and the server. Am I making sense? They build agents and what? The server. So the server, again, the server is not responsible for building, or is not responsible for building. It's just for what? Administration, admin tasks. But the guys that do the building itself are these build agents, which we are going to talk about now, because we are moving to the CI2 that we're going to talk about now, where we're going to configure the agents, the CI server, and what have you. In fact, we would configure all of these things that are seen here. Do you understand, Emmanuel?
Yes, sir. Yes, I do.
Any other question?
Yes, actually, for me, I didn't actually get the stage 7, the 7th stage. I didn't get it clearly. Sorry, I don't.
Okay, no, it's fine. So, stage 7 is just, forget about this icon. Maybe the icon I actually put is actually confusing. Stage 7 is just the end results, a notification to tell you if this build was successful or not. That is all.
Oh.
It's just a notification. The build failed due to this. The build is in pending state due to this. The build pass, and this is, this is a build log. That is just what this number 7 is doing.
Okay.
Do you understand?
Yes, I understand now.
Okay. Any other question? All right. Okay, so moving on. What are the different types of CI tools? There's Jenkins, there's TeamCity, there's TravisCI, there's CircleCI, there's GitLab, there's Bamboo. In fact, in my check-ins, we have about 96 of them, 96 of CI tools that are actually available. So you shouldn't go to any interview session and then they will now ask you that, oh, okay, because you don't know Bamboo, right? We're not going to, move you forward. Or because you don't know Jenkins, we're not moving you forward. Because you don't know TeamCity, we're not going to we'll not move you forward. It is good for you to know all of these tools. It is good. For example, I use Jenkins, I use TeamCity, I use CircleCI, I use GitLab, right? But on production, predominantly, I love to use this guy, TeamCity. I love to use TeamCity because I have used Jenkins before on production that, I had issues with plugins, because the disadvantages of Jenkins, in fact, Jenkins is actually the leader when it comes to CI/CD. But part of the disadvantages is that you have to maintain so many plugins. If you need a plugin for, if you need to do things around building, you need to install a plugin. If you need to do things around notification, you need to install a plugin. Whatever it is that you need to do, if you need to run unit tests, you need to install a plugin. Like Jenkins is very easy, straightforward, but it has a very large ecosystem for plugins. It could be ideal for your own use case, right? But TeamCity, I find TeamCity as a tool that is very easy, straightforward, and does the job. Does Jenkins build the artifact for me well? Yes, it does perfectly. Does TeamCity as well does the job perfectly? Yes, it does. Travis CI, of course it does. Circle CI, it does. GitLab, yes. Bamboo, yes. The end result is always an artifact. The flow for how you configure from number 1 to number 9 is pretty much the same thing for all of these tools. But for simplicity's sake, it is very good for you to understand all of these steps before even jumping on the tools. Very, very important, right? So we're going to be making use of TeamCity in this class. Of course, you can work with Jenkins, you can work with Travis CI, right? So we're going to be making use of TeamCity here in this class. Now, for the TeamCity architecture, it's very simple. This is just the entire, this is just the entire TeamCity architecture. It has a server and it has build agents. So you can have more than one build agent. So this is usually the server, and these are what the build agents. I'll just name them as BA, BA1, BA2, and BA3. So of course, this is analogy, right? You can see these two arrows. There's what? Do, and there's response. Do, response. So it means that the CI server is always connected this way. The CI server is always connected to the build agent this way. And what? The traffic is bidirectional. So that is what this is doing here. So this is just a simple architecture. So a server, and we have what? Build. So you can have as many build agents as possible. Now, why do you need to have several build agents? It's because for your CI, you can have more than one language. For example, if you have Golang, if you have .NET, if you have Node.js and what have you, these agents will be responsible, let's say, for building Go. This agent here will be responsible for building, let's say, Node. And this last agent will be responsible for building, let's say, .NET applications. It's as simple as that. Do you understand? So you don't use Go to build .NET. It will not even work. In fact, your server will even complain. It's just like saying you have asked the cooks to prepare jollof rice, right? Of course, you will need pot, you will need all of the ingredients. Then you are now using microwave to prepare the jollof. Of course, it won't work. Like it's not even ideal. If you need to use a pot to cook the fried rice, use a pot. If you need to grill chicken, right? You don't put the chicken inside. How do I even put it? You don't put the chicken in like just on the gas like that. Do you understand? You need to put it inside an oven. So all of those things, they have their functions. So you use a Go agent to build Go projects. You use a Node Express agent to build what? Node Express applications. You need a .NET agent to build what? .NET applications. It's as simple as that. Then one last one that I usually used to use here is instead of having different agents, to build different applications, what I just do here is I just get an agent and get what I install here. I install Docker. And then Docker can now, build any of the projects that I need to build. So that is just the power of Docker. And you can see where we started the class from. We started from Docker. So usually, you shouldn't have multiple build agents. If you have this, it's fine and good. But what I do most times is just to install Docker, and then Docker should now be able to build any of these projects itself. And that's what we're going to demonstrate here today, right? All right, so let's go. How do we install TeamCity? It's very easy, straightforward, and the documentation too is quite easy. So of course, TeamCity is a very, very simple tool to use, right? It has both the UI, where you can actually make use of the UI to demonstrate all of your build steps. And if you have a very large project, for example, now maybe you're in an organization that has over 500 projects, using the UI is going to be very, very taxing for you. What you can use is the code part of TeamCity. That is by writing some code to be able to automate all of those processes. And the name of that code that is being used by TeamCity is called Kotlin, Kotlin, Kotlin. So you can make use of Kotlin to be able to build all your pipelines itself. So you are building your pipeline using code. But if you have maybe like a small repository of maybe like 50, by the time it's getting to 70, thereabout, you can make use of Kotlin, which I'm going to show you, right? But we won't go, because Kotlin is more like an advanced concept here. So this is the TeamCity's website, right? So they have different plans: TeamCity Cloud, TeamCity Professional, TeamCity Enterprise. So you can make use of this plan. They say that it is free forever, even for commercial use. So it means you can make use of this in the organization. It is written here plainly. It is free forever, even for commercial use. So look at what is here: 3 build agents. So it means what we have discussed here, you cannot have more than 3 build agents. Well, of course, you can make use of Docker to be able to build more. But really, in an organization, you shouldn't even have more than 3 or 4 languages when you are not Google or when you are not Tesla that makes use of diverse languages. So an organization can just be making use of Java, maybe Java and Node.js. An organization can just be making use of Go and maybe .NET thereabout. Then of course you can install all of this on different build agents. 100 build per configuration, of course. So if you want to have over 100 builds, then of course you have to make use of any of these 2 licenses: unlimited users, unlimited build time. All right, so let us get it for free, right? So because I'm going to make use of Docker, right? By the time let us drop the website here for you guys so that you can follow along. It's very, very easy, trust me. Very, very easy to set up. So I've dropped the link here. So by the time you click on get for free and you accept, you read their terms and conditions. I agree that JetBrains may use my name and also by the time you read this through, right, you can also install this on your system. You can install this on Linux, you can install it on Windows, you can install this on Mac, where it's still the same functionality. But because we want to be very flexible, we're going to run in Docker. So by the time you click on that, it's asking you for email. Okay, let me just enter my email. What type of service do you want to use it for? Okay, so because we are DAS, so what does that cover here? FinTech, e-learning. Okay, well, let's choose e-learning. Okay, let's choose e-learning because this is a learning bootcamp platform. Then run in Docker. So let's see where it takes us to. So it is telling me that run TeamCity server in a pre-configured Docker image. So you copy this and paste it, on your IDE here. So I've copied it already here. So I have it here. So this is the command here. Do you understand? So Docker run, let me just go back here and just explain. Docker run, of course, I don't need to explain this for you. Docker run, the name of what you want to give it. You can name this anything, sincerely. You must not follow this TeamCity server instance. You can name this anything. Maybe TeamCity server dash, maybe team pipeline or team whatever it is that you want to do. Then this backward slash is just informing Docker that it should go to the next line and run this next command, right? Go to the next line, that is break and go to the next line. That is what this backslash is doing. So -v is what we call a Docker volume, right?
Yes.
A Docker volume. And what that does is that you need to have persistency so that if your TeamCity server should go down, right? By the time it comes back up, all the data and all of the configurations are still intact. That is why you need to do a what is it called now? A volume binding or a volume mount. So you're just creating a folder on your host, on your machine that is saying that whatever it is that has been saved here inside the Docker. So this semicolon that are seen here is just a bridge between your host and your container. So whatever it is that is here within the container is also saved on your host box. That is what this -v does. So -g, -v, and then of course we discussed -p. -p is just the port. This is the external port, and this is what internal port. So whenever you see this semicolon, is it column that is here? I'm not sure. Whenever you see this column, is a bridge between your box on the left and what? The container on the right-hand side. Do you understand? So, and that was what I did here. But me, I've just gone ahead to remove all of the backslashes and then I added some other things. So Docker run, the name is what? TeamCity server dash, right? I gave it this name. I made it to what? To be in a detached mode. I hope you all understand what this -d means. Do you understand what the -d means?
Yes.
Yes.
Good. Then the -v, right? So I just highlighted the name of the folder. You are not supposed to create this folder before now. Just give it a name. I'll show you where you will find this. I'll show you where you will find it because this is actually a volume. Just give it a name. Right. So I gave this what? TeamCity data. And I left this as the default because this is what is here. You can see it. I didn't change this. Do you understand? So let me view. Let me increase this for you guys. Oh, can you guys see perfectly?
Yes.
Okay. I wanted to zoom in a bit. Okay. Yep. So you're not expected to touch this. So just create the name of the volume. You can call it anything. You can call it Emmanuel data. You can call it ADA, anything that you need to call it. Then the second volume is for logs. So I just called it TeamCity logs. And this same part within the container, I didn't touch it. Then the port, I still gave this 8111. I just left it as default. Then I added something here, network. I'm going to explain what this does and pointed to the JetBrains TeamCity image, which is what is here. You can see here, what we have here and what I did here is the same thing, just that I added the network TeamCity here, which I'm going to explain. So just copy this and run it on your Docker machine or on your server that has Docker installed. So so let's run this here. Although I have this running, but let me just modify the name sort of. So I'm just trying to mute, guys. Sorry. Okay, yeah, cool. So Docker name. So let me just name this as 5. I'm just modifying this because I have this running before now. I'm just trying to rename whatever it is that I have here. Maybe TC data. I'll just put 5 behind all of this. Just the name. It can be anything. So don't say that because I type 5, you also have to type 5. You can name it anything, sincerely. So let me just change the ports here. Maybe change the ports to 9999. So that you will know that I'm not I'm not climbing anything. Okay, so good. So we're ready to run this. I'll just copy this and I'll go to my server where I have Docker. So you can see Docker is running. Docker is running already. Docker version. So you can see the version of my Docker, right? So this is the version of my Docker. So I'll clear this. And can you guys still see my screen? Or should I increase this a bit? Okay, so I've copied the command. I've copied this. And what do I need to do? I just have to paste it. That's all. But your own, because I've already downloaded this already, because I've already run this before, right? That is why it's installed in less than a second. But just can take maybe like a minute or 2 because it needs to pull this image and then run. So let's see what we have. Docker container ls minus latest. So this is the latest container that I run. So of course you can check the log, Docker logs, right? So you can just check it. You can check this last line. What does it say? Open TeamCity page in the browser. Server is running on this page here. Why is it running on? Okay, well, so server is running on 8.11. So why is it running on 8.11? So it's running on 8.11, but you know that I've already specified 99999 here. So it means if I should go to my browser and do so the server, my server name is daas.local and type 9999. Okay, so this is what you're going to have. Do you understand? So this first page is telling you that TeamCity first starts. You can read what you have here. Location of the data directory is just what we specified here. Data directory, this here. It is telling you that this is where you're going to get the data directory. Do you understand? So what do we need to do? Just click on proceed. So this is how you install the server. Now, it's telling you that TeamCity server stores build history and users related data in an SQL database. So for example, if you want to run this on production, right, you need to select your database, MS SQL, and then you can now, select the database host, the instance name, the database name, authentication method. If you want to use Windows authentication or SQL authentication, you have to input the username and the password here and what have you. Right? If you want to use MySQL based on your environment, you supply this as well. If you want to make use of Postgre, same thing. Supply the username, the password, and what have you. If you want to use Oracle, pretty much the same thing. But because we want to make everything to be simple, right? TeamCity has its own embedded database called HSQLDB. So you don't need to provide any username and password. So that's what you can see. It said the internal database suits evaluation purposes only and is not intended for production. We strongly recommend using an external database in a production environment. You can start with an internal database and then migrate the data to an external one after successful evaluation. So what he's just trying to say is that you are not expected to run this on production. But of course, if you have like a small scale, a small scale organization that has maybe like a repo of maybe 10 or 15 thereabouts, you can still make use of this. Do you understand? But production, you should have an SQL server setup. But just to be able to make everything simple, would make use of the internet, right? And then click on proceed. So while that is doing, let me just commit this to the repository so that you guys can have access to this repository. So let me just commit. So the name is called text, or let me just rename this. Is it outside? Okay, let me just put it inside the Golang project for you guys. So if I do ls, so I will rename this for you guys to maybe TeamCity installation steps, right? So ls again. So let me commit this. Here, git commits -m added TeamCity instructions. So let me push it for you guys. Okay, so I've pushed this to the repository, so you should be able to just go to the repository. I'll drop the Git repository here for you. So inside the Golang project, just go to develop and you see it here. So I've added the steps for you so that I can just copy and paste and follow alongside. Okay, yeah, cool. So let's go back. So it is telling me license agreement for JetBrains. So you can read all of the license. Please read through the licenses, the license agreements and what have you. Then you accept the license. Do I want TeamCity to send me statistics? Well, not now. I'll just click on continue. So the next page will be able to take me to the create administrator account. So username, let me give it Ima. So, but make sure that your password is strong, but because this is just going to be for demo purposes only, I'll just make it simple. So my username is Ima, my password is Ima, everything is Ima, which I'm going to destroy after this class. So create the account. So let's give it a few minutes, or sorry, a few seconds. Good. So it's telling me to never. So by the time you log in, of course, you're going to see this page. It means you have successfully, created this guy. You have successfully created this guy, CI server. So this CI server that I'm seeing here is what we have here. So what is the next thing you need to do is to create a project. Now, what is a project? A project is a container. A project is a container that contains your build configurations, that contains your templates, that contains your source control, that contains your connections, that contains what? Everything regarding how you should be able to build your project. You can see that in all of this, I've not mentioned that this is going to be responsible for building. No, I've not mentioned that. It just contains the build configurations, because it's this configuration that is going to send to the build agents, right? It would collect all of the configurations, send to the build agent. The build agent will now be the one responsible for the building of that particular application itself. So project is a container that contains your source control details, connections, build configurations, templates, etc. So let's create a project. Right? So by the time you click on project, you have, a create project here that is telling you that first and foremost, right, I need you to provide your repository URL, project, username, password, and all of that. But usually, I will just come here and click on manually because I don't want this guy to rush me anyhow. Like, let me just create my thing manually, right? Manually. So the parent project is always the root project. That is like the base of whatever it is they are doing. The name here it can be anything descriptive. But what I usually advise people and what we usually do where I work is that we create a project the language of that particular project itself. So if I have a project that is going to be just for Go applications, I'm going to create a project that will now contain all of my Go configurations, my build configurations, and what have you. If I have another project that is going to be for .NET, I will create a project where all my .NET builds will sit under. That's best practice. So let's say, based on what we want to do here, we all know that we have been working on our Go application, right? So let us create a project. So we'll call this Go projects. Let's call it this way. Leave it like this. Project ID is going to automatically generate by itself. Description, if you want to give it a description, you can go ahead, but it's not compulsory. So create. So after it creates, right, you will now need to create the build configuration. Do you understand? Which is what you can see here. So click on create build configuration because remember where we are coming from. We are trying to create all of the configurations that is needed. Remember, we have not even installed the build agent yet. We are just creating all of the configuration needed for the build. So per project, so what do I have here? So this is the project here. This is the Golang project, the dev branch that I want to create a build for. So that is what we want to do here. So create build configuration. So click on it. So it's now telling me that for this particular build project that you want to create, what do you want to give it? So I want to give it Go build, right? Or maybe Golang build, or you can create it my Golang build, anyone. So create it, click on create. Remember, this is under the Go project. So project is like the umbrella. Any other thing that you are doing inside the project, you are creating the build configurations. So that is what we want to create now, right? Build, my Golang build. You can name it anything. So click on create. So what is the next thing? It is telling me that what is the type of what? VCS. So the type of VCS that I was working on is what? Git. Because it's Git that I've been typing here now since morning, right? Is it not Git? Git, exactly. So we'll choose Git here. Type of the VCS is Git. The VCS root name. You can still follow your Go project VCS. It can be anything actually, right? It can be anything here. It's just telling that a unique name to distinguish this VCS root from other roots. Fetch URL. So this is where it now gets interesting. It's telling me that where is the URL of your project, which is what we have here. Remember that we're building our Golang. So how do I get the URL? You might be using GitHub. You can be using other VCS repo, but I actually make use of GitHub, and it's still the same, process. So go to clone, and I'm not cloning. I just want to get the URL repo link. So I will just copy it this way, and then I'll come back here and paste it here. That's all. Default branch, because I'm working on what? Develop branch. That is what I want to, capture for now. If you're working on master, select master. But because we're working on develop, we would say our default branch that we want to monitor is what? Develop. Right? So branch specification, branches to monitor besides default one. So if you have other branches here, let's say I came here and I created a branch. Maybe I named this daas branch, right? So if I create a branch over here, right? So it means I have how many branches? Let me go back to my project. You can see I have 3 branches. So whatever branch that I want to monitor, let's say I want to monitor my daas branch here, I'm going to add them here. I will add all of the branches here, but because we're only working on develop, we'll just leave it at develop. Authentication method. How do you want the CI server to authenticate to this repo, right? You have different options. There's private key, there's username and password, there's anonymous. Anonymous means that your repo does not even have, authentication in place. So it means anybody can just log in, but this is not best practice. So you can either choose password or you make use of private key and what have you. But we're going to leave it at username and password or access token. So my username is, what's my username? My username is, I think is daas Nigeria. Daas Nigeria. Right. My username is daas Nigeria. Now, password. Where do you get your password? So for Bitbucket, you would usually come to settings over here, then come to personal Bitbucket settings. So by the time you click here, so your password here, so please don't mix it up. Your password that you have here is not the password of your login details to log into Bitbucket. If you use that, it will not go. So that is why I'm showing you where to get your access token, because GitHub actually stopped, or Git generally, they've stopped the use of making use of password. That's why you can see access token here. How do you generate this? You come to your Bitbucket. If it's Git, I think it's still the same method. So, but for Bitbucket, come here, click on app passwords, right? Then create an app password. So you can select the permission that you want to for the app password to have, meaning you want, by the time you supply this password, it means you are authorizing TeamCity to read and write your webhooks, to read and write read, write, and administer your project and all that. So you need to be careful on the kind of, what is it called now? The kind of permission that you want to give it. Yeah. So your label, can be, let's say, TeamCity label. This does not really matter. This is just like a label. Label does not really do anything. So by the time you create, let me say.
Sorry to interrupt you. I'm sorry. Please, is this password, app password, is it the same thing as the personal access token on GitHub?
No.
Personal access token on GitHub. I don't know that of
Yes.
GitHub. Let me see. GitHub. Though I don't have anything on GitHub, but let me just see if it's still the same.
It's not the same. It's not the same.
It's not the same, right? I don't use GitHub, but let me see if I can log in. Can we already log in?
On that section.
Let me just see if I have a repository here. Okay, let me see. settings,
Settings here. Then you go to
password,
developer
and
something.
yeah, let me see, password and authentication.
I think you go
So-
to developer settings.
Okay, developer settings. I know
Developer
it's
setting. If in that
Scroll
setting,
down.
just goes down.
okay down, right?
Yeah,
The
yeah.
developer setting, yeah, that's
Developer settings.
yeah,
personal
that's
access
that's
tokens.
that's
Yeah.
that's the one I'm talking about. Yeah.
Okay, this guy,
The
I've not used
token,
this guy
yes.
before. Okay,
Classic,
let's see,
classic
Sha.
one.
So it
Classic.
has different permissions. So I just want to be sure that it's the one.
Okay, let me see.
password.
What is my username? What's my
Just
password?
click
My
the
password.
Babala 05 at Yahoo. The thing will just automatically give
Nah,
you the password.
nah, that's not the password.
Just try it, guy.
Yeah, so I think so. Let me see. I think it's actually still the same thing, but let me see what this. So you can set the expiration, let's say 90 days, and let me see. Let's say we want this configuration. Let's generate the token and say, okay, notes, TeamCity text, which I'm going to delete right now. Generate token.
Okay.
Yes, so this is it. So this is it. So I'm going to delete this now. I'm going to delete this now though, because of course we shouldn't be sharing, access tokens and all. So you can just try this, although I think this should work, but I've not tried it, but of course it should work. So I'm deleting this right now. Right, but this is how to be able to do it on Bitbucket. So by the time you click on the different privileges, you can create it, which I'm still going to delete right now. So it's telling me that here's your app password for whatever. So you copy this, and so you need, by the time you create it, you can only view it once. So by the time it generates, just copy it somewhere and save it, because you will not be able to see it again. That is the bad thing about, of course, it's not really a bad thing, but for security purpose, you'll not be able to see that password again. So I'll just revoke this. Yep. So sorry. Okay, can you guys hear me?
Yes, we can hear you.
Yes.
All right. Yep. So the next thing now is, because I have the password already, I have the app password already. I'll just go ahead and paste this in. So after you finish filling all of this, you can just test the connection. You will know if the username and the password is correct. Of course, you can see it as what connection successful. So you can create. Yep. So you are good with this, right? So it means we've been able to create the Golang configuration, but that is not complete yet. We need to now create the build steps. Now, remember that this our application, right? We have already created the Docker file here. We don't want to build anything manually. I don't want to do this. I don't want to go run web form.go. If I should do this, definitely I should be able to access my application on this ports, on port 8080, just like we know, right? So localhost ports 8080, just like we know. So you can pass in whatever name that you want to pass. This is fine, but we don't want to do this manually. So I will just do this. I would end this. Remember where we are coming from. Remember this, our Docker lights, Docker file lights, whatever. The only thing that I've just included here is my Go test. That is just the only thing. Every other thing remain the same way. So this is what we need our build to make use of. So instead of running Docker build, tag, give it a name, and all of those things, you don't need to do that. The only thing that I just need to do is to configure your pipeline to look for where the Docker file is, and that is all, which I'm going to demonstrate now. So let's go. Okay. Okay, so where are we? Good. So the next thing I need to do is to create the build steps. So here is it. So click on build steps. So build steps is telling you that how do you want this guy here? How do you want the build agent to be able to build the application? So that is what we want to do here. So who can tell me the different build steps, or who can tell me the different steps to take if I need to Dockerize this particular application? Let us have a very quick refresher course. So what is the step here that we need to do? Anybody? So if I need to create an image manually, as we've done in our previous classes, so what is the first thing that we need to do? Oh, yeah, now guys.
After we write our configuration, then we run Docker build.
Okay.
Pointing to the specific we can run Docker build pointing to the entire folder where we are, or to give an absolute path, and then go to Docker run.
Okay, good. Docker run. Okay, so if I need to push it to a repository, what command will I need to do?
Docker push.
Exactly. Docker push. That is all. So it starts from what? Docker build and Docker push. Then the last bit is now what? Docker run.
What about if you want to use clean install? Is that okay?
Clean install to do what?
To run your, it will clean before building the application.
You can. Exactly. Can do that. But remember that what we want to do right now is to build, to create a pipeline to build this image using the Docker file. So let's not overthink. It's just a simple logic that we don't want to carry out now, right? There's no backdoor, there's no backstory. It's just straight to the point, just like I think Michael talked about. They were going to do what? We'll build it and we'll push. That's all. We're automating it. So instead of doing the manual whatever of now typing Docker build, Docker push, that's what we want to do here. We now want to automate it. So let's add a build step. What is the first build step? We want to do what? We want to build. So these are the different builds available under TeamCity. The different builds, like there are so many of them under TeamCity. Now, suffice to say that if I need to build this Golang application, if I need to build it without running Docker, I can still do that. It's very easy. I can still do that. What I just need to select here is where is it? You won't find Go here because I don't know why TeamCity does not have direct Go steps here. So what you just need to select here is command line. So select command line here and then run the command. But I'm going to leave that as an assignment for you guys. So, but instead, we're going to be making use of what? Docker. So I'll select Docker here. So by the time this comes up, it's telling me that what is the step name. So here, we want to do what? Docker build. You can give it any name. You can give it anything at all. The step name, Docker build. So what is the Docker command that we want to run? Build. Remember, we're not pushing. The Docker file source is a file, meaning it is asking that where is your Docker file? Next thing, where is the path to the file? So you will just come here, click on these three icons here, right? Because we have successfully authenticated against our VCS, automatically, by the time we click here, we are going to see everything in our in our develop branch. So what do we want to run? Remember that this is what we want to run here. Remember that we are running develop branch.
Dockerfile.lite.
Dockerfile.lite, good. So I will now select what Dockerfile.lite, right? You can skip this context folder, image platform. You can just leave this like this. Then image tag name. How do you want to tag it? Remember, we can tag it. So this is my GitHub repository. So let's say I want to tag it to, meaning I want to tag it. Remember the process. If we need to push an image to a repository, first and foremost, remember that we need to tag it with the name of the repository, right? Yeah. And then by the time we now push, it will now push that tagged image. So that is just the same thing I want to do here. So let's say I want to push to this guy here, right? I'll first tag it. Tag. Okay, sorry. Formatting is not good here. So let's say I want to tag it to maybe version 5, maybe 5.0, right? Then that's all. Just save it. So this is the first build step.
Can you use latest, sir?
Of course, you can use anything, Emmanuel. This is just an example. You can use anything. In fact, if you want to use latest, you can use it. Whatever it is that you use there. But of course, best practice is saying, yeah, that reminds me. Best practice is saying that you can assign, well, which is what we're going to talk about during our next class, though. Best practice is saying that you can append, the system parameters that actually comes with TeamCity. For example, if you want a build.counter, you want a build.number, whatever it is that you want to append here, you can append it. Now, what this means is that each time you have a build, right, there will be a counter that will be counting maybe by two steps. So if I build this, it's going to build with the name of my repository, column 5.0-1. By the time I build this, it will count maybe like -2 thereabouts. So we can just particularize this and see. But it's not compulsory. But there are some other environments where they want to control the build.counter, or they really want this build.counter to appear in the repository itself, maybe for best practice and what have you. So we can leave the build.counter here like this, and let us save it again. So this is the first build step. The second build step is what? To now push. So you add another Docker build step here and select Docker. So here we're going to call it Docker push. So I'll just select push here. Do you understand? So the same image tag that we gave it. So let me just add anything here and go back and copy what we added here. So I just want to copy this so that will make it uniform. So that the same thing that builds here would also be pushed on the second step. So I will edit this and paste it here, the same thing here. So we don't need to do any other thing. We just click on save. All right. So we have successfully created the build steps. Now, what is the next thing that we need to do? We need to inform TeamCity, because remember that we have added a Docker repository. But how will TeamCity push the images to this our Docker repository. How will TeamCity do that? That's what we want to configure now. So guys, follow me. This is very, very important, right? So where do we need to go to? We need to go to
Credentials.
we need to go to the connections. Sorry, let me change my change my headsets. 1 minute, please. Can you guys hear me?
Yeah.
Yes, we can.
Okay. All right. Sorry about that. So so we need to go back to our projects. So remember that we first created what? A project. And under the project, we created different build steps. So how do you go back to your home, or how do you go back to your default home page? Just by clicking on this icon, right? So by the time you click on this icon, you can see the project that we just created. Do you see? So click on this project and then click on edit projects here. So click on show more, and then you see connections here. Do you guys understand? Remember, we need all of the build projects under the umbrella project to be able to log on to the Docker Hub here to push images to it. So what we need to do is to go under that umbrella, right? And then click on connections. So by the time you click on connection, you can now add connection here. So what do we want to add? We want to add GitHub. We want to add, Bitbucket server, right? Sorry.
I thought we have done that of Bitbucket. We are going to Docker now.
Sorry, Docker registry. Apologies for that. So under the Docker registry, I now need to supply my username and password. So my username on Docker is Babalola05, and then my password, and then I can now test the connection. So you can see it has now successfully connected to this repository, right? So I will save, and we're good. Now, the next thing that we need to do is that right now, let us go back home. Remember that we have to click here, right? So this is the project. This is the build. So this build here, let me edit the configuration. Go back to my build steps. All of these steps here, right? It doesn't know that I have added the Docker Hub URL. It doesn't know that I've actually added the Docker Hub URL. So I need to inform the build step that say, look, I have added the Docker Hub URL, so that whenever you want to push the image to the Docker Hub URL, make use of these credentials. That is what we want to do right now. So what do I need to do? I would, on my left-hand side, click on show more, and then click on build features here. Hope you guys are following me.
Yes, we
Yes,
are.
sir.
Good. So click on build features and then add a build. So anything you are doing, you need to always read all of these snippets, because as simple as TeamCity is, you can easily get confused. So he's saying in this section, you can configure build feature. A build feature is a piece of functionality that can affect a build process or reporting its results. So what we are trying to tell it to do is that before you even start any build whatsoever, the first thing that you need to do is to automatically log on to Docker Hub. just log on to Docker Hub and stay there so that by the time the build is ready, it will be seamless. And then the image will just go to the Docker Hub automatically. That is what this build feature is talking about. So let us add a build feature. So choose build feature. A build feature is what? Docker support. Do you understand? Docker support. So click on the Docker support and then add the registry connection, which is the Docker registry. Click on add, save it. That is all. That is all. So what is the next thing we need to do? We can just go and run this. It will not run because remember what we said here. It is the agent that would have to run and build that particular. So this build now that we've created here, these build steps, they are just instructions, but it is the agent that will now need to, run and build what we have actually done here. So if you click on agents here, what is it telling you? It said you have 0 agent. That is, no agents are available to be able to run this particular application, to be able to build the application itself. Now, let us now go ahead and install our agents. Same thing, we'll go back to the instruction. And this is how you install an agent. So Docker run, let me just copy this here. So Docker run, the name of the agent. So I would name this TeamCity agent daas.5, right? Then point to the server URL. That is, point to this master URL that we have here. Point to this URL. So it's telling me that what is the IP address of this URL. So that is what this is talking about. Server URL is the IP address of this particular server, right?
Well, so can you use another servers for that?
Of course.
Okay.
You can. Yeah, you can. So point to the server and what ports did we open here? Can you guys remember the port that we opened here? Can you remember this?
999.
999.
That is what will now be here. So don't confuse yourself. Remember that 8111 is the internal port, while the one that we exposed here, you can see 9999 is what we exposed. That is what this guy is talking about here. Do you understand? So we'll point you to 99999. Then detach mode, of course, the same volume. So you create this volume. Just give it any name, but because we actually just want to make everything to be uniform, so I'll just add 555 at the back. Then what else? The network. Good. Now, the reason why we have this network TeamCity is that we need to create a network. We need to create a network on what is it called now? On the server, so that both the agent and the server can be in the same network. So that is why we need to, can be within the same segment. Because if I just run this without specifying a network command, right, this agent will not be able to find the server, which is very, very important. If you're actually running as a Docker, within a Docker container. I can also decide to install an agent on my Windows server. I just need to specify, the URL, because of course this is still on my LAN. Because if I should come here and ping that server 10.3.4.12, you can see so far I can reach it. My agent can run from my system. So far it can actually reach the server. In fact, let me even do a telnet to 10.3.4 192.42 on port what 9999. Can you see? It can reach it. So I'm not restricted to just running my agent on a Docker container. I can also install it on this my system here. So far it can reach the server. Do you understand? If I have another server on AWS or on Azure and I do like a cross connect to my system, right? Wherever that EC2 instance is, or wherever that VM is, it should be able to still connect to my server. Most important thing is connectivity. So we're not restricted to just Docker alone. We can run it on Mac. We can run it anywhere. So far it can reach the server. So that's what we are doing here, right? So let's go. So yeah, so that's that. So let's just copy this command. We need to run fast. So let's copy this command and install the agents. So again, I'll just clear this and paste this, and let's install the agents. So let's give it a few seconds. Okay, so I'm a fan of logs. I don't just, so even if I do Docker container ls-l, I can see that it's running. This -l is just the latest container that is running. So I can check the logs, Docker logs, and see what is inside. So what is this saying? What is it telling me? So I'm not seeing any error thus far. So I can just go back and check our agents. So if I should refresh this, you can see that before now there was nothing here, but because we have actually installed the agent, so the agent is showing as what? Unauthorized. So it needs me to authorize this thing, to authorize this particular agent that we just installed, this agent that we just installed. It needs me to what? Authorize it. So you can see that the agent name was blah, 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 but the server returned a new name, sandbox. The agent name will be updated. So this sandbox that I've seen, so always check your logs, just to check what it is that you are doing. Do you understand? So it has given it the name sandbox, which is what we have here, right? So how do I authorize it? Just click on the unauthorized tab here and authorize it. So just authorize it. And we are good to go. So you can see the agents. So now, because we have these agents, right? So let's just go back to our project. Let's just go back to our project. I need someone someone that has been attentive to tell me, based on what I explained here, having Docker, Go, Node, whatever it is here, based on what I've actually installed here, right? Do you think that this project is going to run? Remember that this is our Golang build. Let me just go back to the configuration, our build steps. Remember that these are the different steps that we want to run. So if I don't click on run this way, do you think that this is going to run? Do you think it's going to run? Yes or no?
Yes.
Okay, yes. Okay. Any other person?
For me, I don't know if it will run because from the explanation we got so far, the running process is supposed to be from the trigger of the commit. So because of that, I don't have a definite answer.
Okay. Any other person? Do you think it's going to run? So just to save time, right? Just to save.
No.
Good. No. The person that said no. Why? Olusola?
Okay, so I think from my own understanding, you're saying we will need one or more agents. So as per this one that we have now, we only use one agent. So and in our application, I think maybe we have more than two. Okay, I think it's only good that we have. Okay, most likely is yes.
Okay, I thought it would run because since you explained that we can use Docker as the build agent here, so I think it can run.
Okay.
Don't know if
We're all good with yes, right? I've not heard Ada's voice today. Hello, Ada. Hello.
Here, please. I'm here. My background is a little noisy, but I'm here.
Oh, okay. All right. I just wanted to confirm. Okay. All right. So good practice is that since you all have said yes, right? So let us go and check. So go back home. Go back home and click on your build project itself. And let us say compatible agents. Can you see? It is telling me that that sandbox, that agent that I've installed is not compatible. And so the answer is that it will not run. So why? Why is it that?
not compatible?
Exactly. Why is it not compatible? Let us reason together. Why is it not compatible? It's an agent. And I've already said here that once I install an agent, that is running inside a Docker, it should be able to run the builds that we have here. But I've already done that, but it's still telling me that Docker server.version exists. That is, these are the different criteria, but it's still not compatible. Why do you think it's not compatible?
Can you
Is
run
it because
that?
it's saying
does city support Golang application? Can you run on it?
is it because it is not seeing it as a Golang application?
Nope. Remember that our build project. So I don't want you guys to confuse. Remember that during our build steps, did we specify anything Golang?
We use a command line.
No, we didn't.
Good. See,
Yes,
here,
just like
let me just show you again. Look at the build steps. The agent, even if I'm running Java project or Golang project here, right? So far it is Docker that is handling that. I don't need to specify go build, go mode, or go all of this. And the only thing I just need to do is just to point to where my Docker file is. By the time I point to where my Docker file is, I am good to go. But I've already done that, right? But on our project, on our project here, it is saying that the compatible agents, that we don't have a compatible agent. And,
Okay.
and the reason why,
Let me
okay, yeah, try so that we'll move on.
let me try. I believe I'm just thinking about it because I think everything is done in one server. So the reason why it's saying that is because I think it has to have like up to one or two external like different server or agents.
Nope.
Okay.
Who else want to try? Okay, all right. I actually expected this because, to be honest, when I was also doing this like a few years ago, I was also as confused as you. Now, the issue is what we installed here does not have, I don't want to confuse you with this word, right? But it doesn't have Docker inside itself. What we are running here, this Docker PS, right, is just a container. So see this container as saying that
Okay,
so
I got the concept, sir. I got the concept. Yeah.
Chill. So take this container that you can see, take it as what is running here, as what we have here. Take it as this, right? But it needs Docker to be able to build those build steps. So it means that we need to install Docker inside the container. So Docker needs to be inside this container before this can be met. It's as simple as that.
It's the same thing for Jenkins, where you're installing, you are using a node. You also install Java on it.
Exactly. Yeah. So the same way, so the same way we have this, we need to now install Docker inside the container itself. Do you understand? So that is what this command here is doing. So this one here, you can see that this is just like the plain command, to just install the agent. But to now make that agent to have Docker in it, this is now the command that we need to run. It's still the same command, but we have now passed in some volumes, right? So these volumes that are here are just the volumes from the host itself. Are the volumes from my host. So I know that I have Docker already running on this particular server. So instead of now installing Docker again afresh inside the running container, I can just pass in the Docker from my host and pass it inside the container itself. That is all. So don't confuse yourself about the way it works, but just know for sure that you just need to pass the Docker volume from your host inside the container. And this is just the simple logical command. So let us run that command now. So it means that this server that we, this agent that we ran here is not useful. So let's run the second one. Docker sock.
I have a question. Maybe when you finish what you're trying to explain.
Okay, yeah, it's fine. Okay, so let's kill the other one. So Docker remove -force. So we'll kill this guy because it is not useful for us. All right, so by the time I kill this and then go back to my agents here, you should start complaining that this guy is no longer available. Okay, let us give you some time. Let's hope I've not removed the wrong container. Yeah. So let me refresh. So let us give you some time. You should start complaining that this is no longer available. Okay. So let us now install the one that has Docker in it. So remember, we have to change the ports, and we can give it maybe daas.7 just to make it different from the other one. Fine, let me just remove this so that it doesn't confuse you guys. So we can give this daas.7 Docker name. All right. What else do I need to remove? To keep this simple, let me just remove this. This is not compulsory. Okay, so I think that is that. So I am now passing all the Docker attributes inside this container. So let us run this now. So clear. Let's run this and see. All right. So let's check the logs for this new one. So Docker logs. Okay, let's see. I think it's still okay. So no errors thus far. So you can see that it has renamed it to sandbox-1. So it means if we should go back, right, and refresh. So you can see the other one that we're refreshing and refreshing. You can see that it has finally disappeared. So the first time, let's even clean this first. Let's remove it and reauthorize this. Authorize. Right? So it means it is good. So let's also go back and see if it is now compatible. So can you see now? Can you see that it's now compatible? Because what? We have installed Docker inside the container. Am I making sense?
Yes, sir.
Good. So the last bit is now to what? Is to now run. Is to now run our build. So let's go. Run. So you can see it is running. So you can click on it and check the build log. So you can see that it has finished building already. So how do we check? What we just need to do is to remember that we say that it should send the image to this guy here. So let us refresh it. Good. Can you see it? Can you guys see? So this -1 that you are seeing is that build
number.
Is that build number that we passed. Do you guys understand? So
Yes.
now, so after doing this, right, it means you have been able to automate your pipeline. So now let us now do it from this definition. Let us now do it from this definition here. Right? Commit. It will go to source control. Source control should now be able to build this with our tests automatically. Now, before we go ahead, did we factor in unit testing? Yes or no? Can anybody tell me, did we factor in unit testing here? Yes or no?
No.
Anybody else?
I think
I would
yes.
say yes. I would say yes because what was committed to our repository factored in the unit testing.
Okay, how? Where? Inside which file?
The YAML file.
Sorry? Inside which file?
It's in the Docker file.
Good. It shows that you guys are actually fully inside the Docker file. So you can see the Go tests here. So had it been there is my test was not successful, right? My build is going to fail. Which of course, if we have time, we're going to do some omissions here, and then we'll now repush, and then we'll now see where that takes us. So it means my testing here was included within my Docker file. And with that, I have been able to do a complete CI from develop to source control to build and then test. So now let us now see the automated CI in action. So automated CI in action. Are you guys ready?
So my question just before you proceed.
Okay. Oh yeah.
Yeah. So my question is in that agent side. I don't understand. There is an IP address you put under the server. So I don't know. Maybe I missed it. How you come about the IP address?
Okay, you missed it. You missed it because
yeah.
I already talked about it, but I'm still going to just quickly explain. Now, an agent needs to always communicate with the server. How will the agent communicate to the server? It is through this environmental variable that we have here, server URL. This 10.3.4.42 is the IP address of the host where the server is running, which is my host here. This is my host. IP add more. Can you see my IP address here? Do you understand?
Yeah.
So because the server which is this second container that you can see here. Because this server, I've already exposed it to port 99999 here. It means it is listening for requests, or all requests that is coming from this server on port 99999 will be channeled to the container on port 811 inside the container itself. That is why you can see this arrow here, this arrow that you can see here. You know, it is pointing inside the container. So all requests hitting this server, which is still and which means which is actually synonymous to saying 0.0.0.0. It's just like your loopback address or your local host address, or you can also use the IP address of this server. It's saying that all requests on this server on port 99999 should be channeled inside the container on port 811. Of course, we have actually discussed this. So because this is now the case, I can now take the IP address of my server and then connect it, channel it to this port 99999 that we can see here. Do you understand?
Okay.
Okay, sir, I have a question on this because, well, I have not made use of TeamCity. I'm just using the knowledge of Jenkins to understand every concept on this. Because in Jenkins, we do more of webhook, trying to, like, in case any push or commit to the GitHub, automatically it will now trigger a build on its own. But I didn't see anywhere where you configure your webhook or whatever.
That's what we want to do. That's what we want to do next.
Okay, sir.
Okay, so now let's see the CI/CD in action. Where's my mouse? So. Okay, so it means here, right? If I should make any commits, it should be able to build automatically, right? So let us try that in action and see. Coming back here, let's make a simple commit. Maybe under this our Docker lights. Let's just make a comment, run tests and build. So this is just a comment, right? So we are saving this. And so git status. So I'm a developer now, you know, I've made a modification. I now want to commit this. Right, so I've committed, then let's push. So after pushing this, right, let us now go, it has pushed. So let us come here and see if it's going to build this automatically. So let us watch. I will just be refreshing this page. Let us watch. Okay, it has not taken it. Let's continue to watch. Okay. Can you guys notice anything?
No.
Nobody can notice anything.
Yes, pending.
Pending.
Good. So let's see refresh and see. Is it showing pending, Abi?
Yes.
Good. Let's refresh again now. This pending will not leave this place. That is because, just based on what Emmanuel is saying, under Jenkins, you have to do what we call a webhook. Under TeamCity, you have to do what we call a trigger. So you need to configure what we call a trigger, so that by the time you do an automated commit, right, your CI server should be able to pick that and build it automatically. So let us do that. Where do we need to do that? Just come to your edit configuration here. Then on your left hand side, I'm going to see triggers. So click on triggers, add new trigger. So what does it say? Triggers are used to add views to the queue, either when an event occurs, like a VCS check-in, or periodically with some configuration interval. So that is just what it does. Because of course, there's been an event that we did here, right? So, but it was not built automatically because we didn't have triggers. So let us add a new trigger. So please choose a trigger. Now, what are we choosing? We're choosing VCS trigger.
VCS trigger.
Right? And we save. That's all. That's all. So what do we need to do next? Let us go and make another commit. Or based on that, let's even see if this other one that is pending is going to build, which I doubt. It won't. It's still pending, right? So, but let me just trigger this manually so that it won't cause any. So I will just trigger this manually. So this is usually for some organization that does not want triggers. That is, they always want to approve everything manually. This is just where this happens. So I will just run this manually, right? So that at least it can allow us to breathe. Let us wait for this to finish. It has finished. So it means if I should come back here, I should be able to see 50 dash what?
3.
Are you sure it's 3 or 2?
2.
Oh,
So
okay. Initially you spoke of interval of 2.
No. I didn't set any interval. I just left it.
Okay.
Yeah, so that's why you can see 2 here. So now so based on the triggers we've set, go back here and let us add maybe like a dot. A dot is still an event. So let us add it, commit it, make some box visits by adding a dot. So get status
dot
by adding a dot. Okay, so let me just get status and see just to ensure that it took let me just add something. Run tests and build and run. Let me just add something significant here. Yeah, let me do a git add again. Git status, right? So that's the change that we made. Then git commit. Okay, because of this space, it was complaining of this space by adding dots. So let's now push it. So it's been pushed, and let's see it in action one more time. So let's watch it. It's showing pending.
Yes.
So it has taken it. You can see that I've not touched anywhere.
Yes.
Good. So let's refresh. Can you see?
Successful.
Yeah.
Good. So you can see the flow. You can see that this is even much more easier. You just need to make an update here and just go and sleep. This is going to build it for you and push it to your GitHub. That is all. So this is just the basic CI pipeline, like the basic CI pipeline. So once you're able to understand this concept, you can see that TeamCity is straightforward. You don't need. I didn't install any plugin. I didn't install anything. I just made my configurations and I'm good to go. Do you understand? So so next class, which is going to be next week, we'll now talk about, now, since we have now pushed to Docker Hub, how do we now deploy this application to the target environment? That is where the concept of continuous delivery and continuous deployment comes into play. So let me just give you a trivia. Continuous, no, don't worry. Next week, we're going to just talk about continuous delivery and continuous deployment. So this is...
I have a question.
Please hold on, please. So this is a typical CI pipeline that you find everywhere, anywhere, right? So please try as much as possible to work on this, because your assignment is not going to be as straightforward as this. I will need you guys to kind of like reason well on how to be able to, build the repository that will be shared across for your assignments. All right. So I think this is this. Was it simple enough?
Yes.
This class
Yes.
simple enough for everybody to grasp?
Yes.
Okay, yeah.
But I have a question. If we can go back to our VS Code, if you won't mind.
Okay, so let's take the question one after the other. Okay, please go ahead. I'm on VS Code.
Okay. The web form underscore test.go, must we get that installed manually before we can continue with our processes?
How do you mean by must you get that manually installed?
Because I think to get that you run, if I can remember the code very well, you run is it go test? No, I cannot remember.
Yes.
So must we run that go test manually before the process can be initiated for the testing?
No, because it's already here. Can you see the go test?
Okay.
So let us make a mistake. Just hold on. Let me just show you something. Let's make a mistake somewhere here. Let's say within our application, we passed something that is not logical. We'll save it. Of course, if I run my go test, my go test this way, I know it's going to fail, right? So with this, let's commit it. Git add everything, git status, right? So let's commit it. I will just name this as erroneous code. Okay, so let's push it. Because when TeamCity is running this, right, this go test is going to fail it.
Okay.
Right. So let us watch it in action. So let's see. If it passes, then it means our CI/CD is what? Erroneous. So let's see. Can you see?
Okay.
So just click on it and then go to build log and let's see where the issue. So this is part of your troubleshooting steps. So it failed. So I'm logging now. Let me see where it failed. So let's see. Can you see? Did not complete successfully. So automatically you will know that your app or whatever it is that the developer has committed is problematic because your unit tests has picked it up automatically. Do you understand?
Yes.
Good.
Yes.
Okay. Any other question?
Yes, sir.
Please go ahead.
Okay, sir. When you have a multiple folder or directory on a repository,
Yep.
how can you like build those applications? Like for example, now you have the API folder and you have the front end folder in the same repository. How can you build those? Like how can you run it in the CI and CD pipeline, like not manually but automatically?
Of course, now, what you just need to do is just to create the different builds. Remember, just see this build as an application. You mentioned your API. So your API is a build. Your front end is a build. So just create that same build that way, because I don't want to say this because this is part of your assignment. Multi-state builds. So you create your API, create the build, create your front end, create as a build, create this one, create as a build, and then whenever there is an event, it's going to build automatically. That was all.
Okay.
Don't worry, it's going to be given to you as an assignment, and we're going to discuss this on Friday. All right, any other question? Because that brings us to the end of this class.
Yeah, just one question, please.
Yes, please go ahead.
All right, just a quick one. Let's say as a DevOps practitioner, right?
Yeah.
The tools to use, probably when you join an organization, is that probably the organization will determine what you will use, or they expect you to look for the tool that will suit what they are trying to achieve, when it comes to your CI/CD pipeline?
Good. Remember when we first started our DevOps bootcamp, we said that the DevOps practitioner is responsible for collaboration, or for bringing about collaboration between the development and the operations team. So whatever it is that is going to help us achieve that collaboration, whatever it is that is going to help us achieve that collaboration, of course, part of it is having a pipeline like this, like a CI/CD pipeline, right? You are responsible for finding that tool. It's not the organization that is going to define that, say, look, go and use Jenkins. No, you must use this. No. An organization must not define it's not the organization that is going to define what you need to use. But instead, you are the one that should recommend and advise the organization that, okay, based on best practices, based on this and this, I would highly recommend that you make use of Kubernetes. I would highly recommend that you make use of Jenkins. I would highly recommend that you make use of TeamCity, just based on what they are comfortable on doing, right? I've joined some organizations, where I was one that actually recommended, if you're on Azure, right, you don't even need to make use of TeamCity. You don't need to make use of whatever it is that you want, Jenkins and all. Azure comes with its own Azure DevOps because it is cloud agnostic. Do you understand? So I don't, because I'm purely on cloud, it's not as if I should make use of TeamCity, it won't work. But then Azure has a free CI/CD pipeline already incorporated into the cloud. So I would definitely recommend the organization to be able to make use of Azure DevOps pipeline. But if I'm comfortable with what's it called, TeamCity, I can of course recommend it to the organization to make use of TeamCity. If I'm joining an existing team and they're making use of one particular tool, I won't fight that team to tell them that, no, you must use this. I'll first and foremost study what they have. If they're using Jenkins, I would also check some of the shortcomings that they have with Jenkins. If Jenkins is not fast enough, if Jenkins is having issues with maybe like building, if I have to, wait a longer time for Jenkins to be able to do some stuff, I can recommend to the team that say, look, why don't we do a POC on TeamCity? If I'm comfortable with Circle CI, why don't you do a POC on Circle CI? But the bottom line is, whatever it is that I've done here, it is applicable on any CI tool. Spinnaker, Jenkins, whatever, it's still the same logic. So that when you're not making use of Jenkins, you won't be confused as to where is the build server, where is the build agent. Jenkins has his own build agent, it has its own build server. Circle CI, the same thing. Do you understand? Azure DevOps, the same thing. It has its own server, it has its own agent, the same flow. That was why when I started, I didn't just rush into TeamCity. I just wanted you guys to be able to understand the flow. So having understood the flow, the next thing will now be whatever tool that you want to pick, right? Stick with that tool and, just ensure that the end product is that I am getting my what? My image here. That is the end product. If your Jenkins is not pushing to my Docker hub, then it means there's an issue. If TeamCity is not pushing to my Docker hub, then there's an issue. Do you understand? So that is where would end for today. Any other question?
Yes, sir.
So this will be the last question, Emmanuel.
Okay, sir. Sir, you never include the Nexus and SonarQube in this build and release project. So how can this come in?
Okay, well, so the Nexus and the SonarQube and what have you is for this guy here. Let me see. It's for this guy here. Which we're going to talk about in our next class.
Okay.
Yep. Or do you guys want it as an assignment? Do you want to try to also include Sonar Cloud, as part of your pipeline? Do you guys want to try that?
Yes.
We will try, but it should also be part of the next class.
Yeah, of course. It's part of the next class, because if I start talking about that now, it would take us a while.